Hello seniors, today we're going to see electronic assignment 29, which is about the fundamental theorem of calculus. You're going to be hearing a lot about this later on in the university. But basically, the fundamental theorem of calculus is evaluating a definite integral by hand, which is something that I already showed you how to do last class. So you will see that this electronic assignment actually has nothing new, but rather a little bit more challenging exercises. So, two objectives for today's class. Number one, calculate definite integrals, both analytically and using technology. Basically, finding an integral analytically is how we apply the fundamental theorem of calculus, okay? And then it says find areas under curves between the curve and the x-axis applying integrals. That's what we have learned in the previous class. So, what is the fundamental theorem of calculus? It says, if f is a continuous function on the interval between a and b, and function f is an antiderivative of f, or the integral of function f, in the same interval, then the integral of the function f from a to b would give us the original function, let's say, which we need to evaluate from b to a. And what do we mean by evaluating? It's finding f of b, finding the function evaluated for the upper limit, minus the function evaluated for the lower limit, which is a, okay? That's basically what the fundamental theorem of calculus is about. So here it says the notation, f of x from a to b means finding this subtraction, f of b minus f of a. Then here it says, when applying the fundamental theorem of calculus, although f can be any member of the family of functions of the antiderivative of f, we choose to use the simplest one, that is, one that the constant integration c is equal to 0. We can do this because for any value of c, and this is why I explained to you in the last class, when we have a definite integral, we don't need to write the plus c anymore, because when we evaluate the function for this interval, the c gets eliminated, right? Because we get f of b plus c minus f of a plus c. So the c, the constant value c, gets eliminated, right? That's why we do not consider that anymore. I'm going to leave this here for you to remember. It gets eliminated, so we only get f of b minus f of a. So when we're finding definite integrals, we don't need to write the plus c anymore. Okay, so let's work with these exercises just to see how this works. So example 12, it says evaluate the definite integral without using a calculator. We're going to use a calculator, but just to check our result if we're doing this correctly, okay? So for part A, it says find the integral from 1 to 5 of this function, e to the power of 2x plus 1 over x squared with respect to x. Okay, so for the first part, we'll have to find the integral of this expression, which is something that you should already know, right? We have been practicing a lot with integrals. So if we first separate, we can separate this integral. We can rewrite this as the integral from 1 to 5 of e to the power of 2x with respect to x plus the integral from 1 to 5 of 1 over x squared dx, right? We can separate the integrals into two different integrals and work with each separately. So to find the integral of e to the power of 2x, we would have to apply the substitution method, right? Because we know the integral of e to the power of x only, but here we have e to the power of 2x. So maybe if I convert this to u, if I make the substitution, then I will be able to find the integral of that expression. So to start with, I'm going to say that I'm going to define u as 2x, okay, in order to work with this first integral. So if u is 2x, then the derivative of u with respect to x would be 2. That means that du divided by 2 is equal to dx, okay? So if I apply these changes to my integral, we would have that this is equal to the integral of e to the power of u times, and instead of dx, we're going to write du over 2. So times du over 2. And we already know how to find the integral of this part. So this would be the integral of e to the power of u. I can take the 1/2 out, right? So we would have 1/2 times the integral of EU du. So the integral of e to the power of u is e to the power of u. So this is 1/2 times e to the power of u. And instead of writing u, I can already write its equivalent, which would be, let me write this as plus c because we're finding the integral first, but then we're going to eliminate that. So this is equal to 1/2 times e to the power of, instead of u, we're going to go back to 2x. 2x plus c. So this is the integral for the first part, okay? Then we're going to evaluate it using our limits of integration, okay? So now I need to find the integral of 1 over x squared. The integral of 1 over x squared, you can work with this separately as I'm doing, or you can just plug in it all together into this expression and find it all together. To find the integral of 1 over x squared, this is the same as saying the integral of x to the power of -2 dx, right? So we know how to find the integral of this. It's the first rule we learn. The exponent raises by 1, so this is -1, and we divide it all by the same exponent. So this is plus c. So the answer for this would be -1 over x plus c. So now I'm going to plug in this integral and this integral into the definite integral, which is up right here. So basically what we're doing is we're going to evaluate this expression plus this expression. Let me write that down. So this is the integral, the exercise we're working on, and this is equal to this first part, which is 1/2 e to the power of 2x. And here, since I'm going to evaluate this already, I'm not going to write plus c anymore. So e to the power of 2x minus 1 over x, which is this second part over here, okay? And I need to evaluate this from the value 1 to the value 5. This is how we write the mathematical notation when we want to evaluate the function. So basically what I need to do is plug in this 5 first into my x's, and then subtract that function that we're going to obtain here with the same function, but now evaluated with x equals 1. So let me show you how that works. So we're going to write this as 1 over 2 times e to the power of 2 times 5 minus 1 over 5. And all of this is being subtracted. Let me put this in parentheses. Subtracted minus the same thing, but now instead of x equals 5, we're going to use x equals 1. So e to the power of 2 times 1 minus 1 over 1, okay? So this is what we need to do in order to evaluate. Let me write this in parentheses just to make sure that you understand what I'm substituting. Okay, so if we find this result, that will be the definite integral for this expression, okay? So if we work with this, this would be equal to, let me continue here. This is equal to 1/2 e to the power of 10 minus 1 over 5. And then this is minus, so minus 1/2 e to the power of 2 minus 1. Minus 1. So if I reorganize terms, I see that I will not be able to do much here. So if I reorganize terms, we're going to get as a result that this is equal to 1/2 e to the power of 10 minus 1/2 e squared, and then -1 over 5 minus 1. Sorry, this should be plus 1 because we distribute the negative here. There you go. So -1 over 5 plus 1, that's positive 4 over 5. So that's the only thing we can actually add here. So this would be our final result without using a calculator, okay? But now, let's check our result just to see if we're doing this correctly. Okay, so if we go to the calculator, we're going to go to the menu 1. There you go. And we're going to see if we get the same result that we got here. So we're going to evaluate, we're going to plug in all of this information in the calculator. So remember the steps. We go to math, Then we click on the arrow, and here we have the integral sign. So the integral of, and we need to copy the whole function, e to the power of 2x, e to the power of 2x plus, then fraction, 1 over x squared. And then we evaluate this from 1 to 5. So from 1 to 5, and we're going to get an answer which would be a number. You click on execute, and there you have an answer which is a numeric answer. Let's see if this answer corresponds to our result. So I'm going to write the result here. So using GDC, we got as a result 110.34. So now let's see if this expression we got here is actually the same as that result. So if we plug in that information, 1/2 times e to the power of 10 minus 1/2 times e to the power of 2 plus 4 over 5. Let's see if we get the same result, 4 over 5. We click on execute, and we get exactly the same result. That means that we did this exercise correctly, okay? So that's the fundamental theorem of calculus. It's just evaluating a definite integral by hand, which is doing this right here, okay? So let's see a second example, just to make sure that this is clear. Let's see part B. I think part B is much shorter than part A. So part B says the following. We want to find the integral from -1 to 1. So the integral from -1 to 1 of 2x minus 3 cubed with respect to x. Okay, so for this case, I would again think about doing substitution method, right? Because the other possibility is to expand all of this, but since this is to the cube power, we're going to get a very long expression. So it's better if I use the substitution method and call all of this, I'm going to call all of that u, okay? So by applying the substitution method, we're going to say that u is equal to whatever we have inside the parentheses, 2x minus 3. So then if I find the derivative of u with respect to x, this would be equal to 2, right? Only 2. So if we solve for dx, du over 2 is equal to dx. So now if we replace all of this into the integral, we're going to say that this is the integral of u cubed, and instead of dx, we're going to write du over 2. Okay, you see that when I'm doing the substitution, I do not write the lower nor the upper limit here, because I'm changing variable. You don't need to write the upper and the lower limit when you change variable. When you go back to the original variable, then you're going to rewrite the boundaries, okay? So we know how to integrate this. This would be 1/2 integral of u cubed du, and this is 1/2 times u to the 4th power divided by 4. And we don't need to write the plus c because we're going to find the definite integral. So if we simplify this and we go back to the original variable, which is this expression over here, this would be equal to 2x minus 3 to the 4th power, and all of this is being divided by 8. Now, since we have gone back to the original variable, I need to evaluate this from, according to our exercise, from -1 to 1. Okay, so if I do that, I'm going to find the definite integral. So if I do that, that'll be equal to, first I replace with this number with the upper limit, so this would be 2 times 1 minus 3 to the 4th power, and this is being divided by 8. And then I need to subtract minus, and the same expression, but now evaluated with -1. So this would be minus 2 times -1 minus 3 to the 4th power divided by 8. So now I will evaluate this and see what I will get as a result. This would be, for the first part, 2 times 1, 2 minus 3, -1. -1 to the 4th power, that's +1, so 1 over 8 is what we get here, minus, and this, 2 times -1, that's -2, -2 minus 3, that's -5, -5 to the 4th power, that's 625, so positive 625 divided by 8. So then if I solve this, I'm going to get the result, which would be negative 624 over 8, which, if we simplify, is negative 78. So this would be the definite integral, the result for this expression. You see that whenever we work with definite integrals, we get as an answer a number, okay? In this case, it was also a number, but it was an ugly number. It was this one over here. But you should always get a number when we're working with definite integrals. Okay, so let's see if we get this same result, negative 78, by using the calculator. So if we go back to the calculator, we're going to find the integral of 2x minus 3 to the power of 3, and we evaluate this from negative 1 to positive 1. So we click on execute, and we get negative 78, which is exactly the same result as our integral done by hand, right? So using GDC, we get as a result negative 78 as well. But as I told you, the intention of these exercises were not to use GDC, without using a GDC, for you to learn how to do this by hand, in case you're asked to do this without in a paper 1, for example, right? So that's it. I think that's it. Yes, that's it for this class. I hope this was clear. If not, please let me know. We're going to clear doubts in future live sessions. Thank you for your attention and see you.